Today we're going to work on 277b, which is 27 to 59 odd. So yesterday we did long division, which isn't difficult. And the nice thing about long division is it always works. You can divide any polynomial by any other polynomial using long division. Today we're going to go over synthetic division, which you may or may not know. Did I teach you synthetic division? It's way faster. It's super easy, but the problem is it doesn't always work. So if you have like 3x to the third minus 4x plus 4x squared plus 2x minus 3, if you divide it by a factor that has a single root, like x minus 1, then you can use synthetic division. If you divide it by anything else, so x squared minus 1, or you divide it by a trinomial or anything larger, anything that has more than one root, synthetic division won't work. Now, you can perform synthetic division on the first root and the second root. So let's say I had x squared minus 9. What are the roots of the denominator? 3 and negative 3. It's essentially x minus 3 and x plus 3. So can you use synthetic division? Yes, if you use synthetic division for this one, and then you use synthetic division for that one. But you can't do them both at the same time. So here's how synthetic division works. So let's go back to x squared minus 1. There is just one little trick. You don't divide it by the factor, by the polynomial. So yesterday, on the left side of the box, we wrote the denominator on the left side, and that's what we used. Synthetic division doesn't use the polynomial, it uses the root. So we look at the denominator, and we say, what is the root? 1. So we put 1 kind of in a side box. And then we list all of the coefficients for the numerator, checking to see if we skipped any terms. If we look at this polynomial, did any of the terms get skipped? No. If the terms do get skipped, you have to represent them with a 0. So 3, negative 4, 2, and negative 3. Now you leave a space for one more row, and you draw the division line. And then all you do is drop the first one. So we bring down the 3. And then you multiply and add, and multiply and add, and multiply and add until you get to the end. So 1 times 3 is 3. Negative 4 plus 3 is negative 1. 1 times negative 1 is negative 1. 2 minus 1 is 1. 1 times 1 is 1. And negative 2. And this end box is your remainder. Okay? Now, if you take x to the third and you divide it by x to the first, you're going to get x squared. So these are the coefficients of the answer, the polynomial of the answer, and that polynomial will have degree 1 less than the original, and then the number at the end is the remainder. So when you take this cubic and divide it by x minus 1, you get 3x squared minus x plus 1, remainder negative 2. And it is way faster, but once again, it doesn't always work. And you have to remember, this number is the root, not the denominator. It's the root of the denominator, not the denominator itself. So let's just look at a couple. All right. So if we look at 28, so what is the root for the denominator? Negative 5, so that goes in the box. And then did I skip any coefficients? No. So 2, 7, and negative 15. Drop the 2. Negative 5 times 2 is negative 10. Add those, I get negative 3. Negative 5 times negative 3 is 15. So that's 0. If the answer is 0, what does that mean? No remainder. It went in evenly, which means x plus 5 is a factor of 2x squared plus 7x minus 15. And the resulting polynomial would be 2x minus 3. Now, what do we know about negative 5 on the graph? What happens at negative 5 on the x of the graph? Well, we can't plug in negative 5 because it makes the bottom 0, which makes the function undefined. So we have two options at negative 5. It's either a whole or an asymptote. In this case, what was it? A whole because it canceled. If it didn't cancel, then it would have been an asymptote. Okay? All right, look at number 34. What am I going to put in the box for 34? Well, negative 3. And then, what are the coefficients going to be? 1, 0 for x to the third, 0 for x squared, 0 for x, and 9. So I draw the line, drop the 1, 1, negative 3, 0, 0. So that would be negative 3. That makes 9. 9. Multiply those. Negative 27, negative 27. That's going to be 81. And add those together and I get 90. So what is the answer? X to the third minus 3x squared plus 9x minus 27, remainder 90. Okay, and it gets a little bit tricky with decimals and fractions and square roots, but it's not too bad. Okay, and then if you turn the page, so that first set is all synthetic division, but on the next page you have your option. Divide the polynomials by either long division or synthetic division. So let's look through it and see which ones you can use synthetic division on. So if you look at 47, if I can get there, can you use synthetic division for 47? Yes. What do you put in the box? Not 1, not 3, 1/3. What is the root of this? Well, I set it equal to 0. Add the 1, divide the 3, 1/3. How do we know if we can use synthetic division? If it's an x to the first. So 51, can you use synthetic division? No, you can't. Okay, 57, can you use synthetic division? No. You could, you just have to do it twice. So what are the roots for this? X equals plus or minus 1. So you could use synthetic division for 1, and then you could use synthetic division for negative 1. But the trouble is, what if it doesn't work the first time? Then you're going to be the second time you're going to be dividing a polynomial that already has a remainder, and I don't even know how to do that. So if it works, if both of these work, then it would be nice. But if they don't work, then it's going to be a mess. And so you'd need to use long division. What about, you don't have to do 52, but could you do that with 52? No. That is a quadrinomial, it won't work. So what about 54? No. So use synthetic division where you can and long division where you must. All right? Good luck. Should we leave Aubrey a note? Hi, Aubrey. Next time you should come when you can't stay so long.